Hello, and welcome to the final part of this college algebra exam review. We're almost there. So, looking at this one, it tells us the data is in a table. It represents the population of a bacteria, P of T, in thousands. That's important to note. Versus the number of hours, T, since the culture was started. So he gives us a table and wants us to use the regression capabilities of your calculator to model the data as a quadratic regression equation round to 3 decimals. So, in order to do this, we're going to, first off, have our calculator. I have a TI-83 Plus here. That's the one that's going to be required for the exam. I'll explain like the buttons I put in because I can't really like show you. Just like, I guess listen. I don't know. So, first thing I'm going to do is I'm going to press second 0. That opens your catalog. If your diagnostics are not currently on, put them on. So if you just scroll down to, it's alphabetical order, so scroll down to diagnostics on. Turn that on. Once they're on, they should be on for good. I just want to make sure that they're on because there's going to be good information for this. I don't think we necessarily need to know the diagnostics for this question specifically, but just in general, linear regression stuff or just any regression, diagnostics are really important to use. So after that, I'm going to go to stat. It's kind of like, I don't know, the top middle. It's kind of by the second button, 2 rows over, 1 row, 2 columns over, 1 row down. Press stat, edit, put the list in as of time as L1, put population as L2. Then we're going to press stat again. We're going to go to the right for calc. It's going to be the 5th option, quad regression, because we're doing quadratic regression. It tells us that in the question. That's how we know to do that one. So let's go ahead, do that. And what I got, it gives you y equals ax squared plus bx plus c. Rounds to 3 decimal places. So I got y equals negative 0.173 x squared plus 8.312x minus 1.386. But this one wants it in terms of P of T. So I'm going to rewrite that just in the form that it wants as our final answer. So P of T is going to be I'm going to replace all my x's with t's. T squared plus 8.321 t minus 1.386. So that's the answer for part A. So use them all to determine the time at which the population is the greatest, and we need to round to the nearest hour. So to do this, we have a couple different ways. One way what we can do is we can graph it. So I'm going to open up on my calculator, it's on the very top left, it's y equals. And we can put our equation in. Instead of t's, we'll use x. So minus 1.73 x squared plus 8.321 x minus 1.386. And we can press graph, and it should create the graph for us. We might have to adjust our window. So I'm going to do that real quick. My window's a little thrown off. And we can use that, the equation, graphing it, and we can like make an estimate using that. And you'll get the same thing. The other way you can use is that in order to find when we are at our peak, we can use the formula. It's going to be at negative b over 2a. So that's going to be negative 8.312 over 2 times negative 0.173. And I put that in my calculator. Rounding to the nearest hour, you get about 24. So that is our peak. That is our answer here. And now what is the maximum population? Again, we can use our calculator. We can estimate it that way. Or I can take this estimate I just got and plug it into our equation. So going ahead and plugging it in, I get 98.67. So I did negative 0.173 times 24 squared plus 8.321 times 24 minus 1.386. And I got out 98.67, which makes sense because that's pretty similar to the values we have around. We know the value for 25, and 24 is going to be just before it, and we get something just slightly bigger than that. So that is that for that one. Now, 53, determine the end behavior of the following polynomials. So we're going to have basically two general types of polynomial end behaviors. If it's even, it's going to look like both going up. Sorry, that's a really bad x-axis. Let me try this again. I'll just do it like this. Either they're both going to go up or they're both going to go down. I'll explain how we can determine that. Or if it's an odd, one will go up, one will go down, or they can be flipped. And they get flipped. Like these are if there's a minus sign in front, x to the whatever power. And this is if there is none. It's just x to a whatever power, right? So I'll kind of go more into this as we go. So let's switch colors. So determine the end behavior for the following functions. So the first one is fx is negative 345x to the 224th minus 52x to the 104th plus 27x to the 27th minus 8. So for end behavior, what we're going to do is we're going to look for the x of the biggest power. So our biggest power here is 224. And that 224 is an even number. So that means it's either going to go both up or both down. That's a dotted line to separate the two different ones. And how do we determine which one? Well, if the number in front is positive, it's going up. If it's negative, it's going down. Well, in this case, that's negative. So for this one, our final answer is going to look something like that. There's a few different ways we can write it, but just some notion that as you go to the left, it'll go down, and as you go to the right, you are also going down. And sorry, a little side note. Going back to the previous one, I forgot to put my units on these, so those are hours, and these are thousands of bacterias, I guess. So, okay, sorry about that. I just want to make sure I put that out there. Going back to this next one. So yeah, for this one, you can have either two arrows going down. You could say it's falling to the left, falling to the right, or x goes to negative infinity, f of x goes to negative infinity, and as x goes to positive infinity, f of x also goes to negative infinity. So yeah, there's that one. I'm going to pause and erase, and I'll go to the next one. Okay, going on to the next one. It is, our biggest power here is 333. That is an odd number. I realize I missed a spot right there. Or it won't let me erase, okay. And then we also have a negative out front. So odds normally are like that, but now it's because it's negative, we get flipped, so it's going to be rising to our left and falling to our right. So that's our end behavior. Next up, our biggest power here is 289. We have a positive number in front, 289, that is odd. Because it's positive in the front, we're not going to have to flip it, so it's going to be falling to the left and rising to the right. Next up, biggest power, 54, that's even. It's positive out front, so that's going to be, we don't have to flip it, so it's going to be rising to the left, rising to the right. Next up, 53, that number is odd. Sorry for going a little bit quick. These are all going to be pretty similar. This number is positive, so we don't have to flip it, so it's going to be falling to the left, rising to the right. Even though this 2 pi is some ugly, weird number, The number itself doesn't matter, just the sign of the number. So because it's positive, that's all we need to know. Finally, this last one, that's even, but our number is negative. So normally be going up on both sides, but because it's negative, we flip it, so it's going to be going down both sides, just like the first one. And that's it for 53. Now to go to number 54. Find the zeros and state the multiplicities of the following function. So that's two parts. We first have to find the zeros, then state the multiplicities. Okay, so for this first one, we have x to the third plus 7x squared minus x minus 7. I'm going to do this by using something called factoring by grouping. So I'm going to group the first two terms together. X to the third plus 7x squared. And then I'm going to do a plus, and I'll group the next two together. So minus x minus 7. I'm going to try to pull out the biggest thing I can out of the first one. So the biggest thing I pull out is an x squared. So I'll pull that out front. You're left with an x plus 7. And then I'll pull out the biggest thing I can out of the next one, which is going to be a minus 1. I get an x plus 7. Because I have an x plus 7 here and x plus 7 here, that means that one of my factors is going to be x plus 7, and the other one's going to be what I'm left with. So x squared minus 1, which that also factors. When you have something squared minus a different thing squared, it factors to this what x minus the square root of that, x plus the square root. In this case, the square root of 1 is 1, so it's just going to be like that. So that means that this factors to x plus 7, x minus 1, x plus 1. So our zeros of this are, to set each of these equal to 0, x plus 7 equals 0, you get x equals negative 7, x minus 1 equals 0, x equals positive 1, x plus 1 equals 0, x equals negative 1. So these are our zeros. Circle those. And then our multiplicities are going to be, I'll just put the multiplicities. I'll just put each of those under. So for negative 7, your multiplicity is how many times that's a, quote, repeated root, aka how many x plus 7s do we have? In this case, we only have 1. We also only have one x minus 1 and one x plus 1. So multiplicities, you go to where that root comes from, you see how many of those do we have. So I'm going to go ahead, I'll do part B, I'll do it over here. We have h of x equals minus 6x to the third minus 9x squared plus 60x. First thing I see is I can factor out, I'll factor out a minus 3x out of everything. So it gives me minus 3x, parentheses, 2x squared plus 3x minus 20x. Now, what I can do is I can try and factor that. That might be a little tricky with this 2 in front. Or I can just figure out what this factor should using my quadratic formula. So quadratic formula, if you don't remember, is negative b plus or minus square root b squared minus 4ac all over 2a. So our negative b is going to be negative 3 plus or minus square root of 3 squared minus 4 times 2 times negative 20. And I just realized there's no x in there anymore. We pulled the x out. Sorry, that should have been minus 20. That's my bad. Sorry if that was confusing. There should not be an x there anymore. Over 2 times our a. Also, sorry, side note, a, b, and c are from there. So that's a minus 20. That's a minus sign on a multiplication. Over 2 times our a, which is also 2. So keep continuing to work with this. Square root of, you get 9. And then 4 times 2 is minus 8 times minus 20 over 4. Minus 8 times minus 20 is going to be plus 160, which is going to be minus 3 plus or minus square root of 169 over 4. So to figure out what that is, I can go to my calculator and I'll do square root of 169, and I got 13. So we get minus 3 plus or minus 13 over 4. So if we do the plus side, minus 3 plus 13 over 4, you get 10 over 4, which is simplifies to 5 over 2. Over here, you do the subtraction, you get minus 16 over 4, which is minus 4. So we do that quadratic formula. Well, what does that tell us? That tells us our factors here. So it's going to be minus 3x, and then we'll have an x plus 4, because if I plug in negative 4 into that, I get out 0. And then this next one's going to be a little bit tricky, right? So you'd think this 0 would be x minus 5 halves. But we don't have any fractions involved here. And we have that 2 in from the x squared. So we're going to have to rewrite this by saying this is going to be 2x minus 5. Those have the same zeros, but in this form, it'll multiply out correctly. If you try to multiply x minus 5 times x plus 4, you're not going to get the correct thing. But if you do 2x minus 5, that will work. And you can check me if you want to multiply that out. We get back to the same thing. Normally, you just can't freely move this like 2 over, because that kind of looks like what we're doing. When you do that, we're going to keep that same 0. We're just putting in a form that will work to get back to what we had, because we can't change our equation. So using this from here, we have 3 different terms with x's. And we can set each of those equal to 0. Well, this first one is going to be, we'll get an x equals 0. We'll get x equals minus 4. We get x equals, we just solved for this, 5 halves. Well, how many of each of these x things we have? Well, for all of these, we have 1. So I'll just say all of them have multiplicity of 1. And that is our final answer here. So kind of complicated. We pull out the minus 3x. We have this term. We need to figure out when this equals 0. So we use our quadratic formula. We get our 2 answers, and we can put that in terms of factors. And we need to make sure that we don't have any fractions to begin with. So we don't want to leave it like this. We want to try to rewrite it. These have the same zeros, but this one doesn't have any. This lower one doesn't have any fractions. So that's the one we kind of want to use. And then from there, we set each of these equal to 0 individually. We get what the x is, and because we only have 1 of each, our multiplicity is 1. So let me erase this, and I'll go on to part C. So finally for part C, we have f of x equals minus 4x, x plus 3 to the 4th, x minus 2 to the 3rd, x plus 5 squared. So good news, we don't have to factor. Instead, to find our zeros, we just set each of these individually equal to 0. So we get x equals 0, x equals minus 3, x equals positive 2, and x equals minus 5. Now for our multiplicities. I'll just put each of them under. So for the first one, how many minus 4x's do we have? Or how many specifically of these x's do we have? Well, we only have 1. So that's going to have a multiplicity of 1. Now for our next one, how many x plus 3's do we have? We have 4. So we have a multiplicity of 4 for that one. How many x minus 2's? We have 3. How many x plus 5's? We have 2. And then you're done. That's our answer here. Okay. So, using this, we can use our intermediate value theorem to determine if the function has a 0 on the given interval. So this is our function. Our interval is from 0 to 1. So what are we going to do? Well, we're going to plug in 0, and then we'll plug in 1. And if the signs change, then we'll have a 0 in between. So the intermediate value theorem is basically saying that if you start here and you end there, somewhere in the middle you have to cross the middle. And it's the same thing other each way. If I draw a line between the two and I don't pick up my pen, no matter what crazy line I draw, I have to at some point cross over the x-axis. So I'm going to plug each of these in, and I'm going to see if I have one of them's positive and one of them's negative. Doesn't matter which one is which, just as long as the one is positive, one's negative. So I'll do f of 0, 2 times 0 to the third, minus 3, 0 squared, plus 4 times 0, minus 2. That is 0, that is 0, that is 0. We get negative 2. So I'll do f of 1, 2 times 1 to the third, minus 3 times 1 squared, plus 4 times 1, minus 2. Well, this 1 to the third, 1 squared, 1, those all are just 1. Anything times 1 is itself, so this will become 2 minus 3 plus 4 minus 2. Well, we have a 2 and a minus 2, those cancel. Minus 3 plus 4 is positive 1. So, do we have a 0 in between 0 and 1? Yes, because we go from negative 2 to positive 1. So for the first one, we say, yes, there is at least 1. So, next one, I'll probably go ahead and erase that. Yes, do this a little bit better so it doesn't go on the next one. Again, we're just going to plug in to that each of the endpoints of our interval. So we'll plug in 0, we'll plug in 2. So g of 0 is going to be 0 to the fourth plus 6 times 0 to the third minus 26 times 0 plus 15, which that goes to 0, that's 0, that's 0. We just get positive 15. So now we should try g of 2. Plug in 2 everywhere. Plus 15. And I'll go and put that in my calculator. What I got is 27. So the previous one, yes, we know we have a 0 here. Well, they're both the same sign. So we're going to say we cannot determine. Which you might be thinking, well, why didn't you say no if you said yes before? Well, I mean, I don't know what happens in the middle of this, right? For example, if I were to graph this, right? This is 0, I'll say that's 15. We'll say 27's up here. It could look just like that, in which case I don't. And it very well could do that, but I don't know if it could do that. And then I have 2 zeros. Or it could do that and I have 1. Or it could do that and I have 0. I don't know what it's going to do in between. What this is saying is this is a way to know that if you're guaranteed it. We're not guaranteed in this case. We could, we might not. We'd have to do other stuff to check. On the previous one, though, because it goes from positive to negative or from negative to positive, you are guaranteed that you have to cross in between. That's kind of the difference. So this one, we're just not guaranteed. Finally, for this next one, we'll do h of 1. We'll do always the first part of the interval. So we'll plug in 1. And plugging in my calculator, you get, this is going to be 2 minus 7 minus 14 plus 30. Grouping those together, grouping the positives together and those together, I've got 32 minus 21, which is positive 11. Now also checking h of 2. 2 times 2 to the third, minus 7 times 2 squared, minus 14 times 2, plus 30. Plugging that in my calculator, I get negative 10. So these are different signs. It goes from positive 11 to negative 10. So again, I don't know what it looks like in between, but I do know somewhere it has to cross. So yes. Okay, this next one. Sketch a rough graph of the function. To aid in sketching the function, find the end behavior, zeros, their multiplicities, and the y-intercept. So, the first thing I can use, end behavior. Well, my biggest power is 3. That is odd. So now my end behavior is going to look like something like that. Next, to find the zeros, well, that's going to be when x cubed minus 3x equals 0. Well, I can pull an x out, so that means x times x squared minus 3 equals 0. And I can set each of these equal to 0, so x equals 0, and then x squared minus 3 equals 0. That means x squared equals 3, or x equals plus or minus, don't forget that, square root of 3. In other words, this thing, you can factor to x minus square root of 3, x plus square root of 3. This comes from the difference of squares. You guys might have heard that mentioned. In this case, 3 isn't a perfect square, but we can just do the square root. If you multiply that together, you get x squared minus 3. So now to find their multiplicities. Multiplicity of just a single x, which is x equals 0, is 1. Multiplicity of this one, which is square root of 3, 1, and that's 1. So everything has a multiplicity of 1. I'll circle that. Multiplicities of 1. Circle that, and I'll circle that, because those are the things that matter. So we found the end behavior, it's that. Zeros are this and this. And we find their multiplicities, which are all 1. Next, we find the y-intercept. Well, to find the y-intercept, you plug in 0. And that gives us 0. So now I'm going to switch over to blue to graph this. I'm not going to do much on my axis, but I'm going to mark 0, 0. I'm going to mark negative square root of 3, positive square root of 3. So for my end behavior, I know that when I go off to the left, I go down. So I'm actually going to write the square root thing on top. So when I go to the left, I'm going down. That's for my end behavior. And as I go to the right, I go up. I know each of these are going to have to be at 0, because those were my zeros. And then, because I have a multiplicity of 1, what multiplicity tells us is if it's odd, it crosses. If it's even, it bounces. So in this case, they're both odd. So I'm going to cross. And I'm going to go to here at my next 0, which is also my y-intercept. It happens to be my y-intercept is at the same spot as my 0. So 0, 0 is going to be both a y-intercept and my x-intercept. This also has a multiplicity of 0. Just going to cross. I don't have to worry about like how big these peaks are. We're just doing a rough sketch. So the idea is we've marked our zeros. We marked technically our y-intercept too. It happened to be the same as one of our zeros. And we use our end behavior, and we use our multiplicity to determine if it bounces or doesn't. So now we are done. There we go. That's our sketch of the graph. Now to erase this and to go on to the next one. So for the next one, we're also going to do a rough sketch of the graph. We're going to find our end behavior, our zeros, and our multiplicities. So in the y-intercept, my bad. End behavior. Well, this is going to be a little tricky. So the end behavior is going to be from the x's of the biggest powers, right? So when I have something, my x minus something squared, my biggest power is going to be this first term squared. So it's going to be x squared. Here, my biggest power is going to be x cubed, and I'm going to have this 2 out front. So my leading term is going to be 2x to the 5th, just multiplying those out. There'll be a bunch of other terms, like quite a bit of other terms, but the ones that matters to me 2x to the 5th. I get that again by taking the thing with the x and raising it to the power. And this thing with the x raising the power, just a side note, just for the sake of you guys seeing it. If it is like 2x plus 1 squared, our biggest power is we take the whole thing. We square that whole thing. So there's just that. That's not relevant to this example. I just want to say that so you guys have seen it. The other thing is this 2 in front, we keep in front. Because whatever all this x stuff multiplies together is, we're going to multiply it by 2 at the end. So our end behavior, well, this is an odd number. 5 is odd, so it's going to look something like that. Our zeros, well, we just set each of these equal to 0 and solve, so we'll have 1 and minus 1. Multiplicity, so for 1, I'll put them like down here. Our multiplicity for 1 is going to be 2, because we have x minus 1 twice, and for negative 1, it's going to be 3, because we have x plus 1 3 times. Note, your zeros are going to be the opposite sign of your factors, so don't get those confused. Finally, to find our y-intercept, we just plug in 0. We'll get 2 times, that's going to be positive 1, and that's also going to be positive 1, so we just get 2. So our y-intercept, we're going to have be 0, 2. Now to graph. I'm going to do is I'm going to mark my y-intercept, that's 0, 2. And I'm going to mark my 0. So I have one at negative 1, I have one at positive 1. And now I'm going to use my end behavior, so I know to the left it's going to go down, to the right it's going to go up. But the question is, how does this part look? Well, we can kind of get a good idea just based on like how the graph looks, because we have to go up to reach that point. But use our multiplicities, right? Our 0 of 1 has a multiplicity of 2. So again, for multiplicities, if you have an even, then you bounce. If you have an odd, then you cross. So for this one, where you have a multiplicity of 2 at 1, that means we're going to, 2 is even, so we're going to bounce, so we're going to go down to 1, we're going to bounce off of it. We're not going to go to the other side, we're going to stay on the positive side. If we start on negative, we'd stay on the negative side, but in this case we're starting on the positive, so we stay on the positive side. And for the one at negative 1, you can probably guess by following the picture, but that's going to cross, because for negative 1, it has a multiplicity of 3. That's an odd number, so we're going to cross. So that's my rough sketch of the graph. Now, I'm going to erase this again, and we'll go on to number 58. So we got to use long division to divide the following polynomials. So setting it up, we're going to get 3x plus 2 dividing 6x to the third minus 5x squared minus 3x plus 4. So what I need to figure out is I need to multiply 3x by something to get to 6x to the third. Well, to get from 3 to 6, you multiply 2. To get from 1x to x to the third, we need 2 more x's, so x squared. So that's my first term on top. Now what I'm going to do is I'm going to multiply that times both of these. Now write that right here. So the first one is going to be 6x to the third. That's what we picked it to do. 2x squared times 2 is going to be 4x squared. So I'll put plus 4x squared. But then I'm subtracting this whole term. So 6x to the third minus that is going to be 0. Cancel. Minus 5x squared minus, this minus is going to go on both of these. 4x squared is going to get minus 9x squared. And these carry down. So minus 3x plus 4. Now, I got to figure out, what do I need to multiply 3x by to get to minus 9x squared? Well, to multiply 3 to get to minus 9, you need a negative 3. To go from x to x squared, we need another x. So I'll go ahead and I'll subtract. Multiply each of these by minus 3x, so we get minus 9x squared minus 6x. If we think about distributing this is going to become a plus 9x squared, a plus So minus 9x squared plus 9x squared, those cancel. Minus 3x plus 6x is going to be 3x, and we can bring this down, plus 4. So finally, what do I need to multiply 3x by to get to 3x? Well, they're the same thing, so we'll just do 1. So we're going to subtract, and anything times 1 is just itself. 4, these cancel. 4 minus 2 is 2. So give the answer as the quotient, which is this part. Quotient's the top of the fraction, or not top of the fraction, sorry. It's what you get out from the division, plus the remainder, which is 2, divided by our divisor, which was this. So putting it together, we're going to get 2x squared minus 3x plus 1 plus our remainder over what we were dividing by. And that's the answer. So going on to the next one. Let me erase all this. Our new one is going to be, it gives it to us as a fraction, but I'll just rewrite, I'll write it in the same form we did. We're dividing by x squared. I'm going to put plus a 0x to remind me that I don't have that middle term, plus 2. I don't want to forget and accidentally assume that it's there or mess up somewhere. So I'm just reminding myself I don't have that one. 3x to the 4th plus 2x to the 3rd plus 4x squared plus x minus 5. So what do I need to multiply x squared by to get to 3x to the 4th? Well, I need to multiply by a 3. I need 2 more x's, so x squared. So I'm going to subtract 3x to the 4th. Anything times 0 is 0. So we have 0x to the 3rds. And then 3x squared times 2 is going to be equal to 6x squared. So when we subtract these, we distribute that. 3x to the 4th minus 3x to the 4th, those cancel. 2x to the 3rd minus nothing will give us 2x to the 3rd. 4x squared minus 6x squared will be minus 2x squared. And we just bring these down. Plus x minus 5. So to go from x squared to 2x cubed, well, I'm going to need a 2x. Or I'm going to need 2 to get to the 2, and I need x to get the extra x, so minus 2x to the 3rd plus 0x squared plus, and that's going to be 4x. So we're subtracting all these, so these cancel. This will just carry down, so we get minus 2x squared. X minus 4x will be minus 3x, and then we have this carries down. Minus 5. Now, what do I need to multiply x squared by to get to minus 2x squared? Well, just a minus 2. So minus negative 2x squared plus 0x, and then minus 4. Again, we distribute that. So this will become a plus 4 when we do all this. These cancel. We get minus 3x, and then we get minus. So that becomes a plus 4. Almost cut myself, so this becomes minus 1. So our answer in this case is going to be the top part of our fraction. So it's going to be 3x squared plus 2x minus 2. And then we're going to add our remainder divided by divisor. So plus minus 3x minus 1 over, we divided by x squared plus 2. And that is our final answer for that part. So going on to number 59, now it wants to use synthetic division to divide the following polynomials. Give the answer as quotient plus the remainder divided by the divisor. So for synthetic division, we're going to take whatever we're dividing by. In this case, it's going to be x minus 3. And we're saying our divisor is going to be whatever we plug in to make that 0. So in this case, it's going to be 3. So it's going to be 3. I'll put a little box. And now we're going to put our coefficients. That means the numbers in front of each of the x terms. So 1, 3, minus 1, because it's a negative, positive 7, and 2. I'm going to put a line here. And the last thing I'm going to do is I'm going to put a little dotted line. This, whatever we get into this box at the end, is our remainder. So the first thing we do is you carry the 1 down. Now we multiply this 1 times a 3, so 3 times 1 is 3. 3, and we add each of these. So 3 plus 3 is 6. 6 times 3 is 18. Negative 1 plus 18 is going to be 17. 17 times 3 is going to be 51. 51 plus 7 is 58. 58 times 3, okay, that's like a calculator one. I believe I got 174. Adding 2, that's 176. So the other thing we know is that we started off with an x to the 4th power. When we do synthetic division, we drop it by 1. Each time we do so that means that's an x to the 3rd power. So we have a single x to the 3rd, which I won't put the 1, plus 6x squared, because as we go to the right, we'll go down by a power, plus 17x's, plus 58, and then we got to add our remainder, but we put it as a fraction over our divisor, but we were dividing by x minus 3. And that's our answer. So going on to do that, do it again for the next one. Our divisor is going to be from this, x plus 2, so it's going to be minus 2. And this one's a little tricky. This is a place a lot of people mess up. It's really tempting to do 2, 1, minus 5, 1. But really it's 2, because we have, this is x to the 5th, and then 0, because we don't have any x to the 4ths. And we have 0, because we don't have any x to the 3rds. And then we have 1, because we have an x squared. A minus 5, because we have just a single x, and then a 1. And then on this last one, I'll put my dotted line for my remainder. And I'll go ahead, we'll start. So we bring that down, we get 2. 2 times minus 2 is minus 4. Add those together, you get minus 4. Minus 4 times minus 2 is positive 8. Add those together, you get positive 8 again. 8 times minus 2 is negative 16. Add those together, you get minus 15. Multiply them. Minus 15 times minus 2 is positive 30. Multiply that down, you get positive 25. 25 times minus 2 is going to be minus 50. Add those together, you get minus 49. So we started off with an x to the 5th power. When you do synthetic division, you go down 1 power, so that's an x to the 4th. So we have 2x to the 4th minus 4x to the 3rd plus 8x squared minus 15x plus 25 plus our remainder over what we were dividing by. And that is our final answer for this part. Next up, using our remainder theorem, what that is, that's saying that whatever our remainder is in synthetic division is going to be is going to be our output whenever we do that. So I was stumbling over my words there for a second. Let me show you. So for this, we're going to do synthetic division, and what we're going to be dividing by is we're going to use this minus 2. 3, we don't have any x to the cube, so we'll put a 0. 2 minus 4, 1. Sorry, solid line, put my dotted line. So whatever we get here is the same thing if we would have plugged in negative 2 into that. So this can be helpful if we don't want to like sit around like plugging in these like really ugly numbers. We can do synthetic division, and whatever we get out here is going to be what we would have got if we plugged it in. So we always bring down 3. 3 times negative 2 is minus 6. Bring that down. Minus 6 times negative 2 is positive 12. We get 14. 14 times minus 2 is going to be minus 28. Add those together, you get minus 32. Times the negative 2 is going to be positive 64. Add those together, you get 65. So it means that f of negative 2 is positive 65. The other thing we use remainder theorem for is if we use the synthetic division on it, if we get a remainder of 0, that means it is a 0. In other words, I can try my synthetic division on this number, and as long as what I get in here is 0, then it is a 0. It's weird using 0 twice. But if that is 0, then we can say minus 5 was a 0 of this. So we bring down the 1. 1 times minus 5 is minus 5. Add those together, you get 1. 1 times minus 5 is, again, minus 5. Add those together, you get 4. 4 times minus 5 is minus 20. Add those together, you get 4 again. 4 times minus 5 is still minus 20. Add those together, you get 0. So it means minus 5 is a 0. And we can do the same thing for 2i. So we want to check this one. Fun fact, if 2i works, then minus 2i will also work. That's just a little thing that's helpful to know. 20, a dotted line. So let's see if this works. So 1 times 2i is 2i. And we get 6 plus 2i. Real quick, 2i times 6 plus 2i. Well, we can distribute that. We're going to get 12i plus 4i squared, which is the same thing as 12i minus 4. 12i minus 4. So we're going to get 12i plus 5. 12i plus 5 times 2i. Distribute again, 24i squared plus 10i. 24i squared is going to be minus 24 plus 10i. So we get negative 24 plus 10i. We multiply those, or we add those together. 24 minus 24, those cancel. So we just get 10i. So 10i times 2i is 20i squared, which is the same thing as negative 20. So we get negative 20 there. We add those together with 0. So adding on to this, both of these are zeros. And also, if we tried negative 2i, that will also work. So that's just another fun fact. So both of those were zeros in this one.
Okay, so for this, it says use the factor theorem to determine if x plus 3 or x minus 3i are factors. So what the factor theorem says is that x plus 3 is a factor of f of x if f of, so this x plus 3 is associated with the 0 x equals negative 3. So if f of negative 3 equals 0. So what I'm going to do is I'm going to plug negative 3 in for x. So what is f of negative 3? So that's going to be negative 3 cubed plus 4 times negative 3 squared plus 9 times negative 3 plus 36. And let's see what that gives us. So if I plug all of that into my calculator, I get 18. So since that is not 0, that means that x plus 3 is not a factor. Similarly, x minus 3i is a factor if f of positive 3i equals 0. So let's check. So what is f of 3i? So that's going to be 3i cubed plus 4 times 3i squared plus 9 times 3i plus 36. So let's simplify that. So if I have 3i cubed, that's going to be 3 cubed, which is 27. And then I cubed would be negative I. Plus 4 times 3i squared, so that'll be 9 times I squared is negative 1, so negative 1, so 4 times negative 9 is negative 36. Plus 9 times 3i, which is 27i, and then plus 36. Well, when I add these up, I have 36 and then minus 36, so that adds to 0. And then I have 27i minus 27i, so that adds to 0. So everything adds to 0. So that means yes, x minus 3i is a factor of f of x.